Good afternoon. So as I discussed on Monday, today we're going to have a review for the third exam for this class. The exam is going to be on Monday, May the 2nd, next week. And it's going to be online, as I mentioned already. And it's going to be available in the class time period. So you'll have from 12:30 to 2 o'clock to work on the exam. The format of the exam will follow what you have seen in the first two exams. So you will have section 1 with 10 multiple choice or true or false questions. And then in section 2, you will have up to 3 problems. These are mathematical problems that will be short answer, explanation, description, or mathematical. So you might have some questions about the numbers that you're going to compute. So it's going to be up to 3 problems that you are going to be working on a piece of paper, and then you are going to upload. You're going to scan that piece of paper, or you're going to take a picture of that piece of paper and you're going to upload into the system. So that's the format of the exam. Okay? 10 questions that are multiple choice or true or false questions, and then 3 problems that you're going to work on. You're going to solve, and then you're going to upload on as a file. Any questions about the format? So material handling is the first lecture. We started this third part of the semester going into looking at the material handling part of the facilities design, that component. So we spent some time looking at the different type of material handling equipment that is available for facilities. So this is a long lecture, but again, it's important for you to remember when will you use every type of material handling. So we described 3 main groups: the conveyors, the transporters, and the cranes. And we spent some time discussing when to use each one of them. So it's important for you to remember those details. And then we describe a lot. I mean, show you a lot of pictures and different names. That's not necessarily something that you have to memorize or be an expert on, but you have to understand when to use each type of equipment type. That will be the most important part from that lecture. And then we transition into going in detail on a specific type of material handling equipment, which are the conveyors. So we have lecture 10, part 1 and part 2. Part 1 was focusing on models, looking at deterministic models for the design of conveyors. So in this type of problem, you were assuming that you know for sure what's going to happen in terms of the arrivals that you would expect. And then we were designing for the capacity of the cart that was moving, or the cars that were moving in the conveyor. So providing you with some information about the design, the number of cars, the number of stations, and then using that information, you were tasked to compute the capacity of the conveyor in terms of the car size. And we then do stochastic models. And in this one, we were assuming that the arrivals were random in a sense, because they were attached to a probability. So we didn't know for sure how many arrivals we were going to get, but we know we had some estimation in terms of probabilities that will tell you there's a 40% chance that you will get these arrivals in this station, and these arrivals will go to station 4. And then from this station, that is an input station, there's a probability of this much that these arrivals will go to station, I don't know, 5 or 2 or 3. So that's the difference. So in this group of models, we were more interested in knowing this uncertainty and studying a conveyor in which we know the size. We have split this conveyor into segments, so we know the size of each segment. Segment will fit the size of the product, essentially. So knowing the segments, knowing the stations, knowing the type of rotation, how the conveyor will rotate, knowing all this information, we were interested in computing the speed of the conveyor. So how fast this conveyor should move. And we went through some examples on that as well. So after that, we moved from design of facilities in terms of material handling, and then we transitioned into warehouse operation. So this is lecture 11, and it's also divided into two sections or two parts, in which we discuss the mission of the warehouse, functions of the warehouse, the difference between receiving and shipping operations, and also storage operations, storage space planning. And in part 2, we discuss the warehouse layout models, and we discuss strategies for allocating products into the warehouse. So giving some information about how often these products are going to be moved, the amount of the products, and the space that they're going to occupy. And assuming that we have a dedicated type of warehouse, we were going, and knowing the location of the doors in the warehouse, we were looking at where to put these products in the warehouse, so we can minimize the weighted distance travel by the products. So questions that I got about those type of problems is, how do you know the probability? So if the probability is not given, then there's a 50-50 chance, or the probability is going to be 50% for material going into the warehouse, and 50% materials will go out of the warehouse. So those P associated with the doors are going to be 50%. And we have a problem in the review to talk about that. We're going to look into that soon. The warehouse layout model and the associated algorithm that I just mentioned. And then we also went back to the description of some material handling equipment, specifically for the warehouse operation. And then finally, we discussed the single facility location models. So we had two parts for this lecture, part 1 and part 2. Part 1 was more an introduction, discussing what are the important factors that must be considered when you're looking at this problem. We also discussed some numerical strategies to address different type of problems. And then lecture 12, part 2, focused on the single facility location model. And we also discussed an algorithm to solve this problem. So those are the lectures that are part of this third exam. Any questions? So the videos associated with the lectures are posted in the module. So if you go to the modules, if you want to review what we covered in class, the videos are there, the notes are there, the assignments and the solutions should be there as well. And I think we have a lab, so the lab solution should be there too. So if you notice that something is missing, you can email me and I will upload the file as soon as possible. Any questions about the material in terms of what will be covered? Okay, so should be familiar with this already. This is the same strategy that we use for the first two exams. So how to prepare, study the lecture slides, the labs and the homework. And then if you need any formulas, I'll provide those as part of the exam. The exam is closed book and notes. So you will have the exam link available in Canvas, just like you did for the first two. Clearly show your work formulas used in your solution. This will help me award full and partial credit. So make sure that you show your work. If something is wrong, then I can go and give you, or you earn some partial credit by showing your work. Multiple choice true or false questions will be answered using the computer. And the 3 questions or problems that after the multiple choice true or false or section 1 will be answered using a file or a paper, and you're going to upload the file. So my recommendation is to work the solution in a piece of paper, take a picture, scan it, and upload your solution file. And remember, you can upload a single file for each question, or you can combine those files into a single file and upload all the answers into a single file.
Excuse me, Professor Perez.
Yes.
Could you just clarify one more time how it's going to work with taking the final if we feel like our grade is high enough?
Yes, so I have that as part of the slides for today. So you'll see that in a minute. So after this slide, I think I have that information. So we'll talk about that.
Thank you.
So you have my recommendation for you to use from 12:30 to 1:50 to work on the exam, and then save the last 10 minutes to upload the files into the computer. The exam will close at 2 o'clock. So again, you're familiar with the rules. Any questions about that? So I think this is what the student was asking about, the grading scheme. Oh, this is incorrect. I'm sorry. Yeah, I apologize. This should be. So the right information is here in the syllabus. Yes, right here. So the grading scheme is for the 3 exams, and the final, we have 22% for each exam, and then if you take the final, that will be 24%. But the exam is optional. So if you decide on to take the final, you will use the grade distribution on the right of this slide, in which your homework, quizzes, and labs. When I say quizzes, we didn't have any quizzes this semester, but if I see the need of having a quiz, I'll do it, but didn't do it this time. So homework and labs, 10%. Exam 1, exam 2, and exam 3 are 30%. So what that means is after Monday or on Monday, I will grade your exam, and I will put the grade of your exam on Canvas, and I will adjust the weights for the grading scheme on Canvas. So you will have your final grade for the class using these 10, 30, 30, and 30%. So that grade is going to reflect the no final option. So you will know what will be your grade if you decide not to take the final. If your grade is something close to the next grade, I will encourage you to consider taking the final. For example, if you got a 77 and you want to get into the B, then that will be a good strategy for you. If you have 71 and you want to get to a B, that will be impossible. And you can do the math. Even at 77%, if you do very well, you'll be in the 79 something. And for me, showing me good performance in the final is just good enough. So you will go to the next grade. So that's good performance, meaning 90 or more. Okay, so you go score an 8 in the final. So that's the feedback. So if you take the final, you're close to the next grade. If you are close to the next grade based on the grade distribution without the final, you say you are 77, you're 87, you're 67 or above, and you want to go to the next grade, that would be my recommendation. If not, then again, taking the final will have no major impact. So unless you get a 0, even if you score a 50 and you have I think sometimes even scoring low in the final. So let me not make any statement about that, but I have any students that take the final that get a worse grade than the one that they initially had. Let's put it that way. Okay, so taking the final should be just a way to improve, not to get worse. Okay, so is that any other questions about that? Yes.
Final review.
Final review, that's a good question. So my final review will be basically putting together all the 3 reviews that we had already. So that will be the way to go about it. And then I will send an email with the format of the exam. That's the only thing that is going to change is the format. So I'll let you know you should expect these many questions of this type, and section 2 will be these many questions of this type. Good question. And for the final, you have more time. Okay, so you have 2 hours and a half. So the exam will be similar in size or in time, but you have more time. Okay, so that should be of your benefit. So I'm not going to design an exam that will take you 2 hours and a half. That's not going to happen. Will be an hour and 20-minute exam, and you have more time to work on. Okay. Good. So the other piece of the review. Yes, go ahead. Yes. Yes. So I think I have. Yes, I have a question. Okay, so these are problems that are coming straight from the assignments. So this is looking at, suppose that you have 12 products are received by warehouse according to this schedule. So the schedule is in terms of time periods from 1 to 20. And then you have, so 1 can be 1 hour, 2nd hour, 3rd hour. So these are the events, or first day, 2nd day, 3rd day. And then you have the a number of products that are received in the warehouse for each type of product. So here we have 12. So the question is to find the storage requirements for dedicated and randomized storage. Okay, so for dedicated storage, basically you're looking at each period, and you're finding the maximum for each one of the products. I'm not. So that should give you a 571 pallets position. For randomized, you will have to find the amount of space equal the maximum aggregated inventory level for all products, and that should give you a total of 385. So this problem is more time consuming, that is difficult to solve. It's just finding numbers and making the so yes, going back to the final. If you take the final is going to be included. So you have to prepare for taking the final. making sure that you are gonna score a good grade. What I don't want to happen is, and you show up for the final, you look at the questions, and then you say, I'm not gonna take it. See, that's not gonna be an option. So if you decide to take the final, you access the final, the system will tell me that you accessed the final, so your score is gonna be taken into account. Okay, yes. That's a good question. So for this problem, I mean, you can use a calculator. Let's put it that way. So you can identify the numbers and then add them up. The exam is going to be online, so I will say yes. You can access Excel and do the computations using Excel. Yeah. Good. So the next question is this one, and I think I spent some time talking about this one on our previous lecture. Towards the end, there was a student that wanted to discuss this one. So in this one, this is a problem from assignment 6, if I'm not mistaken. You have an existing warehouse that will be used for storage 6 product families. Warehouse consists of storage bays that are 20 by 20. That's an important piece of information because you need that information to compute the number of bays that you will need for each product. So 20 by 20 is about 400, it's 400 area. So you need that number to compute how many bays will be needed for each product family. So for example, for the first product, you have 2,400 area. So if you divide that by 400, you will need 6 bays. For the second product, you have 3,200 feet square. So if you are gonna compute the number of bays that you need for that one, you divide by 400, which is the area of each bay, and it will tell you you need 8. So that's the information that we have on the third column of that table on the right side. We have the number of bays for each one of the products, and it's essentially the area that is required per product divided by the size of the bay, or the area of the bay, which is 400. So 6, 8, 5, 7, 10, and 4. So dock 1 has been designated as the receiving dock, while dock 2 is used for the shipping. So you have the location of dock 1 and dock 2 in the figure under letter B, question B. So you have dock 1 on the left side, dock 2 at the bottom. There is a requirement and monthly load rate for each product family is shown in the table. So you have the load rate. Those are the T values, TJ values, or T for each product. And the problem is asking to first to formulate the problem using the model discussed in class. So the formulation of the mathematical model we cover in class. Formulation basically has an objective function that is trying to minimize the total travel distance or the total weighted distance inside the warehouse. So that's the summation of T over S, and then the summation of this multiplication Pi Dik J xjk. And then we have 2 constraints. One is looking at each bay, and the other one is looking at each product. And you want them to be equal to 1 for each bay and equal to Sj for each product. So the formulation is standard. It's not going to change. The only thing that is going to change are the parameters for the model. And then using the information that's given, we have for each product the area, the number of bays, the load rate. So we can use the load rate and the number of bays to compute this ratio, TJ over SJ. And then we are going to sort we're going to rank the products according to this ratio. So going from the largest one to the smallest one. So that will be 6, then 3, then 1, then 4, then 2, and then 5. So that's the ranking. That ranking is telling me which products are more relevant in terms of placing them closer to the doors, or meaning I want products that are moved the most to be located in the best locations in the warehouse. Best locations in terms of distance travel, weighted distance travel. So if I have a product that is not moving too much, I can put that product far away from the doors. If I have a product that is moving a lot, want to locate those in the best locations in the warehouse, so they are more, it's easy for me to access them. So that's the first. I mean, if you're solving this problem, you have like two parts. The first part is to deal with the ranking of the products, understanding which products will have priority. The second part will be to identify the best locations of the warehouse. So to identify this or to compute, we have an FK equation that is equal to the probability of using a door times the distance from, or the centroid to that door, the centroid of that cell to the door, plus the probability of using the second door times the distance from the centroid of the cell to the location of the door. So for example, here, as I mentioned already, if the probabilities are not given, we are going to assume that PI is 50% to 50%. So I'm going to compute the F1 value, or you see FK, when K equals 1. So F of 1 will be equal to 50% times, I'm gonna call this my first cell. And I know this is doc 1, and this is doc 2. I'm sorry, this is wrong. Those are based on this. Okay, so the distance from this door to the center of that cell is gonna be 10, 30, 40. Plus 50% times, let's say, all the way here. So that's how much? This is 20 by 20, so 70, 70, 80, 100, 120, 140, 160. So this is gonna be 100. You will have to, yeah, do it manually. So yes, 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 I know. This is how many cells? Yeah, so you'll see that some of them will repeat itself, right? So for the 70s, but yeah, I understand. So you have to do for each cell the F value, and then once you get the values for each one of them, say this one is 100, as we saw here. Then we have the cells that we can identify the best locations for the warehouse. And then based on these ratios and the number of bays that are needed, we can allocate these products to the bays. So for example, we start with product 6, because it's the first one in terms of the ranking, and we need 6 bays for product 6. So I want to locate 6 in the best cells available. So for me not to get confused, let's see. Oh, sorry. Yes. So it's sorry. So it's 6 by 400 by. We only need four bays, right? Where's that? Oh yes. Sorry about that. I was looking at the wrong number. So we only need 4. Apologize for that. You only need 4. So that's why we place them here. So the next product is 3. So for 3, I need 5. So 1, 2, 3, 4, 5. Again, I'm still in the 70 area. For the next one is 1. So 1 is 6. So I'm going to use the rest of the 70s, and then I need to transition to the next one. So the next cells that give me a good value are the 80s. So I'm going to use 3 of those. Then 4. Requires 7. So I'm going to use these 80s. 1, 2, 4. Then I take the 90 and I need to use 200s, which are these 2. Then get 2 requires 8. So we use the rest of the hundreds. So here's 1, 2, 3, 4, 5, 6. I still need 1 more. So I'm going to use one of the 110. And then the last one is 5. So we use the rest of them. So what is the important thing here? In addition to identify the ranking of the product, is that you place them in the right base. Yes. Yes. Oh, yes. Sorry. Yeah. Right here. So I have 7, 8. Yes. Thank you. So we take the 110, and then we still need another one. So we have to use the 120. Good. And that's the solution of this one. I think this, I mean, if you see something like this in the exam, that's a problem that probably is going to take you the longer time. Yeah. Yes.
I guess the colorful one, the one above it.
This one.
How would you make that chart?
So you say the formula for F1 that is equal to 100. You have to repeat that process for each one of the cells. Okay.
Oh, I see. Supposed to be the
Yeah. So if you use the second cell, Now the distances are going to be different. Third cell distances are going to be different. And then you have to compute the value for F1, 2, up to all of them, yes. The probability is based on the amount of product that goes in and goes out for a specific time period. So you have a lot of movement, how often you use one of the doors versus how often you use the other door, basically. Yes. Yes. Good question. That's there's gonna be 50-50. We've been using that. But remember, it's based on the probability of using a specific door. So if you're gonna be traveling a lot for during that time period, movement going out, yes.
Corner, where do some of those numbers come from? So it's just like 1 comma and I just a 32, like where?
Yes, so that's a good question. So I think for this problem, we don't have 32 ways, right? How many we have?
40.
40. So that should be, yeah, should be 40 right here.
And it doesn't tell us the size of the warehouse, so we're expected to just count the squares. It talks about the storage.
We get the figure right there for the warehouse. That's given. Yeah, yeah, it's right there. Yeah.
We just, I guess, whatever is stored there. kind of-
Yeah. So this is part of the problem, right? So that figure is given, so you have an understanding of the location of the docks and the size of the warehouse. And then this is the problem that I would try to solve first. If you get something like this, because this is a problem that you can solve pretty quickly. Okay, so here we have actually County News Observer plans to rent the building space for a new print shop within the city limits. The locations for the current distribution centers, expected deliveries, and possible locations for the facility are shown in tables. And so in figures below, there's no, yes, so there was no figure here. Apologize. So determine the optimal location for the new print shop. So we have the information about the current distribution centers here. We have the X coordinate, the Y coordinate, and the weights. So as we discussed last time, we're gonna separate these two into a problem for X and a problem for Y. So we first start with coordinate X, and we sort the centers based on the value for the X coordinate in ascending order. So that's what we have here. So all the information that's given for X is sorted based on that coordinate value. 5, 15, 25, 30, 35, and 50. The weights are gonna be sorted based on that, and the center also. So then the next step will be to do the accumulation of the WIs. So for the first one, it's just gonna be the first value, 200. For the second one, is gonna be 200 plus 400, 600. And then for the next one, 600 plus 500 is 1100. 1100 plus 600, 1700. 1700 plus 300, 2000, 2000 plus 400, 2400. So that's the values. Those are the values for X. And we repeat the process with Y. And now using the Y coordinate, we can sort the centers based on in increasing order. We also sort the WIs based on the coordinate. And then we do the summation one more time. 300 plus 200, 500, 500 plus 400, 900, 900 plus 400, 1300, 1300 plus 500, 1800, 1800 plus 600, 2400. So now we have the information that we need. Next step will be to identify the threshold. So the threshold that is going to allow us to make a decision. The formula for computing that threshold is the summation of all the weights divided by 2. So in this case, the summation of all weights is 2,400. We divide that by 2, and the answer is 1,200. So that's my threshold. So now I'm going to go for X, and I'm going to identify the center for which the aggregated W is greater than 1,200. In this case, that number is 1,700, and it corresponds to center F, and the coordinate value is 30. So that's what the value that is circled, right? So you look at this summation of WIs. First one is 200, next one is 600, next one is 1,100, the next one is 1,700, that's greater than 1,200. So that's the coordinate that I'm going to use for the new facility in terms of X. Then I move to Y, do the same as 6Is. So I look at the summation of the WIs, 300, 500, 900, 1,300 is greater than 1,200. So that's the coordinate that I'm going to use for Y. So it's 20. So the final location for my facility should be in coordinates 30 and 20. If you solve this problem using the mathematical formulation, you should get number close or the same number for the location. Questions? Okay, so if there's a question in the exam asking you to locate a new facility, you have to follow this method. Okay, gotta follow this method. You want to get make sure that if you don't get the right answer, you get partial credit. Make sure that you show me this process. We should be able to get the full credit. Questions? I think that's the last slide. Open the floor for any other questions. So if there's no other questions, then I'll talk to you guys later. Make sure that you log into the system on Monday to access the exam.
So just for clarity, this was our last class then, right?
Yes, this is the last class.
Okay.
Monday is exam. Yeah.
Yes, sir.
And Professor, that's the final on Monday?
The third exam is on Monday.
Okay, and when is the,
Final is scheduled by the register. So the date, I don't recall the date right now, but it's in the syllabus.
okay, because I looked in the syllabus and I couldn't find it.
I can share that to you now. So here's the. So May 11.
Okay,
From 11 to 1. Okay, so I'll stop the sharing now. You too. We'll talk more.
Thank you, sir.